Hello, everybody, and welcome to this webinar on managing crisis with data-driven intelligence. In this webinar, I want to show you the technology and the possibilities with respect to our optimized demand forecast. And seeing as believing, I show you a small demo version of our intelligent ERP in Business Central and a corresponding BI dashboard. Let's look at the first overview. Maybe let's consider the picture from the bottom. In the bottom, you can see the ERP. Here we have a screenshot of Business Central. We install, or the basis for intelligent ERP is a connector. This is the typical app you may know from Business Central and so on. So this is some kind of software you can install in Business Central. And this connector is responsible for a continuous update of all the available information you can get from a mathematical algorithm. This connector updates tables. This connector updates data, updates actionable insights. So the basic idea is to transform data to a mathematical algorithm, you can see on the left here, and to get an action from a mathematical algorithm. In case of the optimized demand forecast, we transfer, we update or transform, upload is maybe the right word. We upload the item ledger entries for certain articles to the algorithm, and moreover, we update calculation parameter. We upload calculation parameters for this mathematical algorithm. For instance, such a calculation parameter could be the horizon you want to forecast, you want to predict in the future. 4 weeks in the future, 1 day in the future, 7 days in the future, or even 1 year if your data is good for this 1 year forecasting. So now all the needed data for the algorithm is transferred to a cloud service for forecasting. So this cloud service for forecasting takes these parameters and calculates a demand forecast based on different time series models. Of course, we support typical time series models like exponential smoothing, like the ARIMA forecast, and so on. But the advantage of our algorithm is that he calculates all the different models in an automated way. So this is a fully automated algorithm that computes the best time series model for the available data. As a result, the algorithm delivers a demand forecast with some quality indicators like the standard deviation. And these demand forecasts and these quality indicators can act or yields a basis for decision making. For instance, this demand forecast is transferred to a table in the ERP, in the demand forecast table, and then you can work with this table as you typically would do. You can modify, for instance, parameters. You can run your planning routines you have, and so on. So the benefit is that we can compute actionable insights, a demand forecast, and other optimization stuff I will show you later in an automated way via a connector and via optimizing algorithms that we provide as a cloud service, as an online service. Let's show, I will show this in Business Central and how this works in Business Central. And I need to check my setting. Since this is it's a demo platform where I freeze the data. So according to May last year, so I need to check. Yes, this is my working date for available data. And I need to check whether the ERP service, the intelligent ERP service is running. Our system is ready, as you can see in this table. So, and then here you can see in the wall center, there are 3 intelligent apps installed. You can see our basis connector here in this area. And then there are 2 intelligent apps are installed, namely the demand forecast I mentioned before, and moreover, here is also another app installed, namely the optimal material precision. Yes. which computes optimal planning parameters for the material requisition. So how can you configure a forecast? For this, I can go to the forecast configuration worksheet in this app. And then here you can see a table with different requests for an algorithm. Here we have 1, 2, 3, 4, 5, 6. In this example, we have 7 requests for different articles. This article IEVA10011. Moreover, you can also configure requests for all item categories. You can filter requests according to variants for articles. And moreover, you can filter requests according to different location codes. So when I want to have a forecast for this article, in the first line, I simply push the button, send request. So now this request is open since we submitted, as here you can see in the information box, a request. For what, or what's the configuration of my request? I say, okay, I have a granularity of week, so I get a forecast for every week. So I get 1 number per week. I consider 12 weeks in the futures. So I get, so to say, 12 numbers for each week, 1 forecast. I consider 5 years of data in the past. This is this -5 epsilon. And what I want that the result is stored in the demand forecast with this name. I took the same name as the article. Here, of course, you can choose a different demand forecast. You can take an arbitrary demand forecast. This is standard Business Central logic. And this, so to say, this request is released. So the status is set to released. Here, I pushed the button in a manual way. I simply clicked send request. Of course, you can also automate this request when you select a certain scheduler. So, for instance, you can say, yes, I want that the numbers of this article is refreshed every night at 3 o'clock. So you can run the calculation in the night at 3 o'clock, and then the request is sent to the algorithm at 3 o'clock, and then you do some calculation stuff and results the result in your data. Here in the connector, you can see, we come back to our request. Here in the connector, you can see a full history of our requests. So here's our request. I sent it 2 minutes before. Here you can see, this is the date of today at 11:12, 2 minutes ago. And you see here, you can see our request is already processed. So the status was open a minute ago. However, now we have new results since the status is processed. Moreover, the result is imported at 11:13. Here you can see it here. So our requests were all 11:12, and now we have new data available at 11:13. So then let's look at our result. I go back to the slide. Here you can navigate to the result. So let's see the last request. Again, you see the last request, status is proceed, everything went fine, since there are 0 errors and 0 warnings. You can also see, of course, the result. This is the result of our article, as I said, on a weekly basis. So for every week, here is 2nd of July, then the 9th, then the 16th, and so on. Here you have the predictive quantity, 27.73, and so on. And moreover, you have some quality parameters for your forecast, namely the standard deviation here. This somehow quantifies how precise is our forecast, how sure we are with our prediction. And again, you have the information when you imported the results for your forecasting module. This is basically when you want the result which comes from the algorithm. And now this result is automatically integrated in Business Central. So let's see at our demand forecast. Here you can see the demand forecast which I written down in our request. This is the demand forecast for this article. As I said, you can name it as you want. I want a view by week. And now, of course, here are all the articles included. Since I have just for one article, the table is empty except for one line, namely for this one article I took for presentation purposes. I need to scroll down. Of course, you can filter, but I scroll down. And here you can see, maybe you remember the results of our forecast. This were 27 point something. However, when we integrate the results into the ERP logic, we round the results with respect to the information from the ERP system. And this is fully integral if you want. So here you have the predictive results for the next 12 weeks, 27, 23, 19, and so on. And of course, now you can configure a request for all of these articles written down here, and then you have a complete result of demand forecast simply by pushing a button, simply by pushing the button send request. The same logic and the same applies if you want to plan and optimize your material requisition parameters, your disposition parameters, and so on. I will come to this later on. Of course, we deliver more than just these numbers, since you need to verify your results. Here I took a dashboard. This is actually a dashboard from a customer with where we are allowed to use the data. And here you can see what the algorithm does. Of course, the algorithm does many things in the background. However, it in particular computes the trend of the article. Here you can see that the trend of this article is slightly decreasing, as you can see here in this black dashed line. And moreover, you can see the prediction here on the right. This is the prediction. And you can see this is the gray area. What's the standard deviation? So here you can see the standard deviation of this article is quite huge. But this is expected, since here you can also see that you have very different ups and downs of this article. Of course, this is done for every article. Here you can see. And of course, you can see the effect when you reduce your history. Here I took 4 years into consideration for this article. And moreover, you can reduce the history that should be considered, and where you can see what's the trend in my last 2 years, for example. Here you can also see the trend is decreasing, and then here you have a prediction of the future. Moreover, I only show you here the basic algorithms in the past. We have more than these algorithms, but these are the standard algorithms which the algorithm uses. In this case, we use 4 forecasting models. However, we can also use more than 4 ones. I just showed you here the results of our standard routine, which are quite good if you just considering these squares. You can see that you have different ups and downs, and you have your prediction here concerning the uncertainty. However, of course, if we enrich the methods we have in the background, then the results becomes preciser and preciser. Yes, and this is a dashboard. This dashboard has more than 1 page. Here I simply showed you the page for the article. However, I also have other page where the data scientists can see some KPIs for different forecasting methods. However, I don't want to go into detail of this dashboard. This is basically a dashboard for our data scientists that can show you what's the quality from a data science perspective for each forecasting algorithm, so that the results are transparent for you. Let's come back to our slides. So if you just consider this forecasting mechanism, of course, this can be transferred to every intelligent ERP service. In the past, whereas you in the past have a manual maintenance of the demand forecast, you have to plug in your numbers by hand, some maybe 1 time per month. For this, you have to ask your sales people, yeah, what is your plan for your sales cycle next month, and so on. So this is very, tedious. It's very annoying to do this by hand every month or every year. Some customers only have such a plan just for 1 year. So moreover, these numbers are typical to the best of your knowledge, with respect to gut feeling, with respect to experience, and so on. Maybe you have an accuracy of 60% of your manual guess. And of course, this yields in static planning with buffers. Since you have, in this scenario here, you have a planning horizon for 1 month. So this is some kind of static 1 month. However, if you use the technology of intelligent ERP, you can automatically update the tables every day. So, and since you can update these buttons on tables every day, you can switch from a dynamic, from a static planning to a dynamic planning of the coverage over the next week, for instance, or for the next 2 days, or whatever. What's appropriate range, for example. Moreover, you have numbers with mathematical precision, since, as I showed you, we take the trend of the product into account, we take seasonalities into account, we take outliers into account, and so on. And that's why, of course, depending on data and so on, but there are customers where we achieve the accuracy of more than 85%. So, and since you have now this accuracy, this daily update, this automation engine behind, as I said, you can switch from such static assumption in your planning to a dynamic range to, and that's now the benefit, reduce buffers in your planning. And when reducing buffers, when reducing inventory, of course, you can save a lot of money. The connector is responsible that a powerful demand forecast is available in your ERP system for each article and all its variants. Doesn't matter how many articles you have in your ERP system. We have customers which more than 10,000 articles, and of course, simply push the button and you get a forecast for every of this article. As I said, you can automate your calculation through this using this configurable schedulers. You can get an schedule overnight. You can get results overnight, every week as you want. Moreover, there are other capabilities of our connectors. You can reference originals with follow-up articles. It might be the time that you have an article that is an end of time, where the life cycle is ended. However, you have a follow-up article for this. And of course, you can reference this old article with a new article, such that you can make prediction for new articles in your ERP system without a history, simply by saying, this is the old one and this is the follow-up article. Moreover, we can also group different articles regarding their properties. If you maybe have a red chair and a blue chair, and you simply say, hey, I want to have a demand forecast for my chairs, then you can say, okay, please aggregate the numbers for the blue and the red chair and simply make a prediction for the chairs. This is sometimes very important to have a rich databases for forecasting. And we also have customers who have old data in Excel sheets, since they introduced their ERP system in 2019, and they have ERP data or data for forecasting from 2014 to 2018. And of course, we also can manage these old Excel data. For this, we have a small table in our connector which you can use to enrich your forecasting module in your ERP system. We calculate for every request, we calculate trend of the article, as you saw on the Power BI dashboard, where you have a decreasing or an increasing line. We calculate seasonalities. Is there a monthly season? Is there a yearly season or whatever? We calculate outliers. Outliers are very important to optimize the quality of our forecasting module. And moreover, we also detect forwards. Maybe there are articles with a lot of zeros. So this is an article where you have maybe 1 or 2 or 5 warehouse movements. And of course, if you only have 4 data points, there is no series prediction possible with. And we detect these kind of articles and say, oh, here we can produce no accurate forecast since there are too many points. We also calculate uncertainties since we compute the standard deviation. So you have an insight how accurate our forecast is. So you can also quantify uncertainties. So in your prediction in the future. And of course, depending on how great is the uncertainty, there are more buffers needed in your warehouse or less buffers. If you have a very precise forecast, you can reduce inventory according to the demand. And of course, if the uncertainty is high, you can increase your safety stock to prevent for an stock out. And as I show you, for everyone, we have a quality report in terms of a Power BI dashboard where you can see what's the quality, what are the results, and so on. What are the parameters for the engine? How do we calculate this forecast in the back end? This forecast is, as you may be read in various blog articles and so on. The idea is that we consider all the available history, which is shown here in this golden area. And then we compute different splits. In this picture, we compute 3 splits. And then we do the forecasting routines for these 3 splits. And of course, then we have 3 results, which we can compare with the actual data. So we have a wet forecasting result from the past, which we can compare with the actual data from the present. This can be done 3 times or more than 3 times. This depends on the amount of available historical data. And out of these information, out of these 3 information, we compute the best model for this data to compute the actual result for the future, this black box here. This is basically a standard routine in this area forecasting. However, the benefit of our model is that this routine is completely automatized. So we have a complete automation of these procedures. So there is no manual interaction needed to compute appropriate forecasts for your demands. As I showed you, all the algorithms are deployed in the cloud. A forecast for one article is maybe you can use your computer. However, if you have 10,000s of articles or thousands of articles, then your computer might be not sufficient. So and that's why here we can scale in the cloud as we want. Moreover, we have a standardized IT infrastructure for the provisioning of algorithms. As I said, we have more than one algorithm. We have different algorithms. And here we have now a standard which you can use in your ERP system. So we can use the connector technology. We can use our deployment infrastructure for the cloud to produce new algorithms that can help you for your planning purposes. You have no efforts for maintaining the security and the availability of these cloud services, which is a huge benefit since they're continuously updating security standards and so on. And all this is done by COSMO Consult. Since this algorithm is ready in the cloud for you, you can simply deploy them in your ERP system just by installing the connector. So you have a very short implementation time if the algorithm in the cloud is appropriate for you, or if the algorithm in the cloud is ready for you. Then you simply need to connect to the algorithm using our connector technology in Business Central. The customer completely manages the upload of data, the release of calculations, and the download of results. So the customer is the active part in this picture. So you can say, I want to upload these data for an algorithm. Now I want to download the results in my ERP system. Moreover, the cloud also manages the different calculations that are sent to the cloud. There is a batch in the center of our engine, and this batch orchestrates all the incoming calculation jobs and so on. So you can request, I don't know, 100 and more calculations, and the batch organizes that you can get your results as fast as possible. How can you use us, or how can you use these algorithms? For instance, this forecasting module. Yeah, our customer journey is, in this sense, quite simple. The idea is you can get our connector. You can install these connectors in your ERP system. Then you have to do a setup where you can plug in credentials, a subscription key, some passwords, and so on, such that you are connected to our cloud. And if you are connected to our cloud, you can immediately start to configure requests and to compute forecasts. So that means if the connector is installed, you can immediately, as I showed you, form a request and say forecasting. Then you can evaluate the quality of your algorithms in a 3-day non-binding test. Moreover, you can book a session with our data scientists to show, these are the quality parameters from a mathematical perspective. Your data is very good for forecasting because of this, this, and this, and so on. And this is additional service we can give you from our data science department. So the idea is here, we want to have a very fast access to your data such that you can see with your data what is the quality of the algorithms and what's the working flow for your business, what's the benefit for your business. And that's the main purpose of this kind of journey. As I said, we have different assistants ready to use. We have the time series-based demand forecast I showed you. You also saw that the installed app for the service level focused inventory minimization. So based off time series, based off this forecast with this quality information concerning uncertainty, we can calculate order proposals that minimizes your inventory. So at which time and point you should order which article at which supplier, such that we can minimize your inventory and such that we can reduce order costs and warehouse costs. Moreover, we are at this time working on a capacity planning service for the optimal setup times of machines. So which article should be scheduled for which machine, such that we can reduce the setup times of machines. This is an actual project with a customer from Austria. And moreover, of course, the service runs again in the cloud, and of course, the service is standardized, so everybody can use this service for production planning. And moreover, there are many individual requests for forecasting and optimization. As I showed you, this is a framework where we can incorporate many different algorithms from an ERP perspective. So if you have a very special planning scenario, for instance, you want to optimize the mixing of different chemicals, or if you want to optimize your logistic, your transportation, also on. These are typical cases we are confronted in this setting. And of course, we can also deploy an individual service for you in a project comprising of this algorithm, comprising of a connector for the integration in the ERP. This infrastructure is ready for such ideas. Now we are at the end of our webinar. Thank you very much for your attendance. Thank you.